Hello, everybody. Good morning and good afternoon to all. Thank you so much for joining us for another edition of the Internet of Water Coalition's regular webinar series. My name is Paula Basili, and I will be your host for today. And for those of you who might not be familiar with the IOW, we are a group of organizations and individuals really united in a vision of an open and interoperable water data ecosystem. And so part of how we help to bring that vision to life is by providing information, community sharing spaces, as well as technology and tools to help make sharing water data easier across boundaries. And so we're excited today to be featuring a tool from one of our partners. And we'll be joined by Sara Larsen from OpenET to share a presentation of that. Before we get started, just a couple of quick reminders for housekeeping. One, if you do have questions and answers, questions are always welcome. Please use the Q&A function down below. We will be addressing any questions until the end of the presentation, but if you think of a question or a point of curiosity, feel free to jot it down in that Q&A function below. If you do have any kind of technical difficulties, the chat is a great place to let our team know, and we'll work behind the scenes to hopefully get things fixed and ready to go. And so with that, again, I'm really excited to introduce Sara Larsen, who's the CEO of OpenET, to kind of help share a little bit more about the platform, what's new, and how it fits into the vision of easier and better water data sharing. Welcome, Sara. Thanks for joining us.
Thank you, Paula. Let me go ahead and share my screen. Great. Is everybody, can you see that, Paula?
Yeah, that looks great. Okay.
Okay,
Over to
great.
you.
Thank you. All right, technical achievements. Great. Thank you so much. Good morning and good afternoon to some of you. It's wonderful to be here with the Internet of Water. Many thanks to the Lincoln Institute and the Center for Geospatial Solutions and the Internet of Water teams for having me. As Paul mentioned, my name is Sara Larsen, and I'm the CEO of OpenET Inc., which is the nonprofit arm of the OpenET effort. Our nonprofit works on behalf of the consortium of OpenET partners, those talented researchers and program managers and developers who make all of the ET data magic happen. And the nonprofit works to advocate for OpenET and act as a point of contact on all things OpenET. So if you have some questions after the webinar, please do reach out and we will work to assist you. One side note, for those of you who know me, I used to work with and for the Internet of Water team, so this is a really lovely reunion and a real thrill to be working with them again. And one thing to note, I want to thank the Internet of Water folks for their really tireless advocacy for open water data and fair data sharing principles. It is a slog sometimes, and it's these really small shifts in the ways that we think about data and sharing critical information over the longer horizon that make a tremendous difference. So with that, OpenET is a great example of the value of transparent and open data sets. So let's go ahead and dive right in. Some of the things that I'd like to cover today, what is OpenET and why does ET data matter? Talk about open science and open data approaches, why our approach is so important. Data to decisions, and go over some grower case studies. And then lastly, what's new and what's next for our team and what we see on the horizon for sharing even more ET data. All right, so why is this so important? Here's a map that helps to illustrate some of our increasing challenges around drought and water scarcity. The map is a little bit old, but one could argue that things have gotten a little bit redder in recent years across the globe, and we're experiencing even more impacts from climate change and acidification. There's some really big challenges on the horizon, and some would argue are already on our doorstep. So it's important to note that the demand for water is competing across sectors, and especially around expanding populations and an increased need for agriculture and for more food. Given these constraints, effective water management is not just advisable, it's absolutely critical. Here's another map that helps to underscore how important it is to understand both water supply and water demands. This one is of the drought monitor in the US, just from last week. And what you can see is there is a lot of orange and a lot of red. And it's not just in the Southwest. We're seeing more frequent flash droughts and even just regular droughts in the eastern side of the country. And the drought this year extends all the way up to Maine. I'm in Utah in the southwestern United States, and over 50% of the area out here is facing severe drought. And that has been persistent for many years. And if you've been paying attention to the news, you've probably heard a lot about the Colorado River Basin. There's just a lot of stress about how to manage our water resources. So farmers and water managers are having to figure out how to sustain communities, ecosystems, and continue to grow our food with less and less water. It's a little bit like trying to balance your checkbook without knowing how much water you're spending if you don't understand the water use component. And this is true across the West and across the globe, that those kinds of data sets have been really hard to come by. And OpenET works very hard to fill that water use data gap. Before we talk about that, though, it's important to understand ET a little bit first. So what is evapotranspiration? What you're seeing in this graphic is precipitation and irrigation coming across a landscape, percolating into the soils, maybe even running off to a different landscape, but also being evaporated from the soil and being transpired by plants and vegetation and crops. So combined, we have evaporation and transpiration combined to evapotranspiration. And luckily for us, we have some satellites that are circumnavigating the globe that help to pick up on that energy flux at the plant level and give us an idea of how much water use is being taken up by crops and by vegetation. This is really powerful and an incredible asset for us to be able to have access to satellite imagery like this. We also have models that take that satellite imagery and interpret it into crop water use. Once we have that ET data, what can it do for us? ET data can give us a picture of water use in the agricultural sector across many different crop types grown across the US, and also across a wide diversity of irrigation management and agronomic practices. OpenET has made this critical water data available at the field scale. That's 30 by 30 pixels, 30 meter pixels, or about 0.2 acres. So very spatially resolute. Our data are available with extremely low latency, just a few days, depending on cloud cover conditions. And it's an incredibly helpful proxy when meter data or in situ data measurement is very scarce. So when you don't have meters, ET data can really help. And again, this is from Landsat data that are widely available, but used to be very difficult to use and also very expensive. So the mission of OpenET is to put this incredibly useful set of information into the hands of those who need it the most. Our hope is that this data will further support and enable farmers and growers to optimize their operations and make the most of every drop of water that they have, increasing their irrigation efficiency, supporting precision agriculture efforts, increasing yields, or enabling folks to conserve water where they want to or need to. Whatever any given farming approach, you can only generate better data. You can only operate better if you have an understanding of ET data across your farm, your vineyard, or orchard, and have that ET data in your back pocket. Keeping up on ET can help you detect vegetative water stress early in the season and understand ET anomaly patterns and further understand drought impacts on crop conditions and crop yields. On a basin-wide scale, having access to ET data can support water planning and management by providing historical data and trend analyses, planning for the future, supporting reservoir operations with timely use data. ET data can also be used to support water conservation programs, providing an estimate of historical water use and then water conserved, and as supporting data for local water markets, programs, and transactions. ET data are helpful for agricultural applications, but we are also working hard to expand our utility in forests and grasslands and rangelands. OpenET data can be used to evaluate the impacts of forest management treatments by looking at ET pre and post-treatment action. It can be helpful for understanding long-term headwater and forest health, and it can help with our understanding of climate change impacts, fire fuel loads, and our wildfire risk. Once a fire occurs, ET data can help us understand the recovery after a fire. There are so many applications where ET and OpenET data can be applied. We're seeing an incredible uptick in the number and variety of use cases for this valuable data set. But before we get to use cases, let's talk about open science and open data and why this approach to sharing data is so powerful. I'd like to introduce you to the OpenET consortium team, who are devoted to making sure that the ET data in OpenET are the best and most advanced in the world. These are the folks who make the magic happen and maintain all of our ET models for peak performance, and that support our ongoing efforts to increase OpenET data accuracy and utility. In the early days, around 2016, 2017, these folks got together and decided to pool their efforts in support of open data and open science, not necessarily knowing, but hoping that making this data freely available would make an impact on water management and sustainability, especially focused in the West. Now, with the launch of the OpenET platform, the refinement of our models even more, and the recent expansion of the data to the East Coast, these partners, the amazing partners and use cases that have been developed, these consortium partners are seeing their vision come to fruition and come to life. This picture is taken at the first OpenET user conference outside of Albuquerque, New Mexico in 2024. And if you were lucky enough to attend this conference, you'll know it was one of the very best that has been organized. And we are planning to recreate that magic at a second user conference later this year. But I'll tell you more about that in just a minute. The team maintains these 6 models, EE metric, Alexi, Dysalexi, SSEBOP, SIMS, PTJPL, GECBOL, and each one of these has some strengths and weaknesses in different landscapes. They're all pretty amazing estimates of ET using that satellite data. And then we take an average of these 6 to create an ensemble value that takes out a couple of outliers. And generally speaking, what we recommend is when folks have questions about which model they should use for their application, we say, hey, why don't you start with the ensemble and see how that's performing? And most folks are off to the races with that. We always get questions about the accuracy of OpenET data. And so our consortium partners put together a first of its kind assessment of accuracy for the OpenET models from across the country that included a whole bunch of ET benchmarking sites and really gave and shed light on the relative accuracy of ET data, modeled ET data, when compared to in the ground measurements. And generally what we're seeing is, especially for cropland applications, it is very accurate and is very helpful for applications that need their data sets to be within plus or minus 10 to 15%. We're also working on many improvements to our data sets and using this benchmark data set to evaluate those improvements. The results of that study were published in Nature Water in 2024. And since that time, we've had quite a number of other studies that work to evaluate OpenET against other flux ET measurements or against meter data to try and help us benchmark our models even further. What you'll see on the nature water cover is a really beautiful picture, a snapshot of what the ET data look like in our OpenET Data Explorer. So let's take a deeper dive into what that looks like. If you go to openetdata.org, you'll see our Data Explorer. Open an account and jump right in. And you'll see on the western half of the country some field boundaries. It's very colorful, looks very nice. And basically, you just zoom in and out to areas of interest to see your field boundaries and different colorations for different levels of ET. So the darker blue colors would be more evapotranspiration, and the lighter yellows would be less. When you click on a field, you'll also get a pop-up window that shows trends over time. I'll just zoom in on that. And in that window, you'll see our 6 models and also the ensemble ET value. And you can see it changing over time. You can see a seasonal trend in ET and even detect anomalies where you might be experiencing drought or lessened irrigation or lessened precipitation. So very helpful set of information. And then if you need to, just click on the download data button and you'll get a CSV file or, a variety of different ways of accessing the data through this platform. If you don't want to use the field boundaries, then you can switch over to our raster view, which has now been expanded over to the entire eastern half of the country. This was just last December. It is a huge advancement for our team to be able to share data farther to the east. And we're really excited to see what kinds of use cases and applications come out of this expansion. This is the format where if you want to digitize your own set of polygons or just look at landscape ET, you would use our raster data set. That's how you would get access to anything that's outside of a field boundary. The OpenET Data Explorer is just one way to access our data. You can also interact with it in a programmatic way using our OpenET API. You can grab our data sets in bigger quantities off of OpenET Google Earth Engine data catalog. The OpenET open source repositories have all of our models and information about how the models operate. And then lastly, we have a custom tool called OpenET Farms. It's the Farm and Ranch Management System, which is a recent release of an application where somebody can upload their own information and get custom ET data right at their fingertips. So I'd like to give you a little tour of the Farms tool. Again, this is a platform where a farmer or a grower could upload their own boundaries. They can draw their own, or they can select from our field boundaries in order to get a custom report around ET for their needs. Here's just an example set of fields. Somebody might come in here and select these different fields to try and understand them a little bit better. When they select their fields, you're then asked to generate create a report. And this is where you can pick your different time intervals. You can get daily data, you can get monthly data, you can set a start date, an end date, and you can pick which models you're most interested in and some other variables that we offer through our interface. And then click to save your report. The Farms tool is going to go retrieve that information from our API and then bring it back to you in the form of a report that makes it really easy to understand for your given time frame and for your given boundaries what your ET or your other variable information are. You can download that report, you can print it out, and even run some cross-field comparisons. If you want to look at ET across a variety of fields, this can be incredibly helpful for understanding your operations. and irrigation efficiency, detecting anomalies, things like that. And then we've basically made it so you can take it out in the field on your phone and have those reports emailed to you in an ongoing way. So if you want to get this on your phone while you're out in the field every 3 days, once a week, once a month, you can set up those parameters to do that. We've had a lot of accolades about our farms tool. Here's one fellow, Dwayne Roth in Kansas, who says, if I had told my father about this 15 years ago, he would have called me crazy. Thanks to OpenET, I can now monitor water loss from my crops in real time. By combining it with data from our soil moisture probes, this tool is enabling us to produce more food with less water, and it's revolutionizing agriculture. Basically putting a really important data set in the hands of farmers and growers who we think can do so much good with that. I'd like to share a few examples of how our data are being used in decision making and share with you some grower case studies as well. What we're seeing over the past few years since the platform launched in 2021 is some incredible uptake across the West. Nevada and Oregon are using OpenET for groundwater management in locations including the Diamond Valley and the Harney Basin. California is using OpenET for water use reporting, for groundwater management, and irrigation scheduling. We estimate about $29 million in savings for farmers through the use of OpenET when they're quantifying water use in the Delta region. We also have studies that estimate that about 127 million in projected value to almond farmers through use of OpenET for irrigation management is a potential. Our data are being used by multiple groundwater sustainability agencies or GSAs in their water budgeting and reporting back to the state for SGMA compliance. And one of the other really lovely statistics that we're seeing is that currently about 40% of our data retrievals from OpenET have been identified as being for the purpose of irrigation management. And that is a big increase over what we've had in the past. We used to be accessed primarily by water researchers and academia, and we're seeing a really big uptake in folks who are using this for irrigation. And of note, our API actually does support irrigation management tools for other commercial companies like Ag Monitor and Crop Manage. So we're seeing some really amazing uptake in California and that region. In the Colorado River Basin, we are seeing an incredible set of uses for OpenET data in support of basin-wide accounting. In 2022, the Upper Colorado River Commission and the Upper Division states of the Colorado River Basin adopted one of our OpenET methods for use in agricultural water use reporting. Reclamation also adopted E-metric at that time to support their consumptive uses and losses reporting. And the Lower Basin Reclamation Office recently adopted that as well. There is a big push in the Colorado River Basin to have some additional instrumentation that ties into remote sensing, an increase of from 5 eddy covariance towers to about 25 eddy covariance towers, just to support, well, not only to support, but in part to support our validation efforts when we look at how well our models are performing in these different areas. We'll have that in situ ground truthing information to compare to. That is incredibly helpful for our researchers in making improvements to the model. We also are seeing OpenET data being used in conservation programs. The Upper Basin developed a system conservation pilot program. Utah has a demand management pilot program where they use OpenET data to estimate historical consumptive use and conserve consumptive use when a farmer fallows as part of the program or does some crop switching or split season irrigation, things like that. We are working to support the tribes, states, and reclamation across the basin by performing some really bespoke analyses around model intercomparisons, the QA/QC of extra data, effective precipitation, estimates for consumptive use, and basically data services and customized access, training and outreach, and ongoing data and tool development. So we're really trying to make a difference in a really fraught Colorado River Basin. We think of OpenET as one of those foundational tools for understanding this really important part of the water supply and demand cycle. Think of it as a third-party validated data set, best available science, or a Switzerland that can provide data that is sometimes a little bit contentious and can be a little bit tricky to evaluate. A little farther to the east, we're seeing some uptake of OpenET data to support the Ogallala. Kansas, Oklahoma, and Texas are using OpenET to support their farmers that rely on irrigation from this all-important aquifer and try to sustain it for a longer period of time. Nebraska is using OpenET to improve groundwater management and also to further their water accounting in the Twin Platte District. So a lot of use cases we're seeing all across the country. And one area I want to highlight, since we've expanded to the East Coast last December, we would love to see some new use cases on the eastern half of the country. That would be absolutely amazing. And I encourage all of the folks on the webinar, if you're in the East Coast and you want to kick the tires on OpenET data, please do so and let me know, and you can be our first Eastern use case of OpenET data. We'd love to see that. So please reach out. Okay, last thing, what's new and what's next for our OpenET team? This is always really exciting because people want to hear what's on the horizon for OpenET. Some things that we're working on very hard. We want to improve some of our meteorological inputs and work to remove some of the bias in our weather data that is part of our calculations. We're working to expand our field boundaries to the East Coast. We found that we have some pretty good field boundary data sets. There are also some places where we need some improvements and there are some gaps. So we are working with states and partners across the East to further refine those field boundary data sets and expand to the East Coast. Incidentally, when we do that, we'll be going from about 4.5 million polygons to about 12.5 million. And we'll be working very hard to maintain the performance of our platform. So you'll still be able to zoom in and out and have things redraw relatively quickly and easily. We're working on approaches around effective precip. So this is a really important data set. If you have ET and you have effective precip, then you can derive your net ET from other sources. This could be irrigation, it could be subsurface flows, those kinds of derivative products. So we're working very hard on putting together an effective precipitation data set. We are working with partners on new forestry and rangeland management use cases. So how can OpenET data be used in these other more bespoke ways across the landscape? If you have a forest thinning exercise, what is the ET pre and post? If you have a fire, what is the ET pre and post fire? And how to evaluate watershed health using some of those metrics. We are working on how to make OpenET data more resolute. So how can we use other missions and data fusion approaches to either address some of the cloud cover issues or to increase our resolution? One of the things that we're really looking forward to is the Landsat Next mission. And we're very hopeful that we'll have an increase in the frequency of overpass days so that we can get even more refined information out to our users. We're working very hard on international pilots. We have partners who are running models and trying to put these data sets together in different locations. We have a teammate, as I mentioned, in Brazil, who's working very hard on how ET data look for the Amazon River Basin, which is very exciting. Mexico, India, Denmark, and a variety of new and nascent places. So we're excited when we are able to publish those pilots and work with those partners to see what kind of use cases they might have for our information. And lastly, our developer team is working very hard on making some farms enhancements. Our application's pretty new, and folks have kicked the tires on it and given us a lot of feedback, and we're making those improvements as we speak. As key takeaways, I just want to share with you, OpenET democratizes this ET data. We provide it freely available at no cost within some pretty high quota limits. And the data are from 99 to present. And we offer it from the field scale to basins and then across the contiguous US. So really, if you have an interest, go and check out what our data look like in the Data Explorer. It's very easy to access, and we really are working to democratize this information. Our data services support a wide variety of registered users. We have about 15,000 registered users for our platform right now, and they are using this data on such a wide variety of management applications. It's pretty incredible to see. We are working on making sure the OpenET data are rigorous and best available science. We have put our money where our mouth is in terms of putting out peer-reviewed accuracy assessment in Nature Water, and we're continuously updating those analyses. We have some really amazing partnerships all over the country, Pacific Northwest with California, in the Colorado River Basin, in the Ogallala, and then hopefully some new partners in the East as we wrestle with drought and climate change in those regions as well. One thing to note is that our OpenET science team, this is what they do. They are nationally recognized leaders in remote sensing of ET and the science of ET, and they are continuously working to advance the models and algorithms that support our OpenET platform. And like I said, as we get access to more mission information, as we explore things like data fusion approaches, and even artificial intelligence and machine learning, I think that there is a very good chance that you're going to see some rapid improvements in the ET data that we're sharing. And we think that this is only going to get better. This is the kind of data set that is so helpful and useful if we have more in situ ground truthing and more metering with which to understand the physics and the interplay between land and the atmosphere. We're going to be making improvements. And then lastly, the transparency and reproducibility of our data are really key. When we have multiple partners at the table, our data allow them to have a shared understanding of water quantities and where those data are coming from, whether it's with partnerships or even with negotiations where people are trying to get to a shared understanding about water use. So incredibly helpful for this to be open science and open data. The last thing I'll share is a shameless plug for our second OpenET User Applications Conference. We are planning this conference for November 17th and 18th in Salt Lake City, Utah. We just released a call for abstracts, and that's our little QR code here in the corner. So if you get a moment, please take a picture of the screen, or I believe Rana's going to add to the chat a link for that call for abstracts. Please either go to the OpenET website or LinkedIn page, or follow this link to submit your abstract for the conference, and come and share your experience using OpenET data. The first conference showed such a wide variety of applications and had so much energy. It was really rejuvenating for our OpenET science team as well. And they came away from it recharged and so excited to continue our exploration of the importance of ET data. With that, I just want to say thank you so much. Please do reach out to our team if you need anything. My email address is here, and if you need more technical support through the Data Explorer, the API, you can go to support@openetdata.org. We also have a huge variety of videos and tutorials on YouTube that you can access if you just want to understand how to get started. And just appreciate all of the time that you've taken to learn more about OpenET. With that, I'll give it back to Paula and we can go to Q&A.
Thank you so much, Sarah. What a pleasure to learn about all the great work that you all are doing, and also what a beautiful platform too. It looks so easy to use and like a lot of rich information in a really nicely presented way. So thanks for sharing that. Excited to kind of start exploring. We've got great questions in the chat, and so since we do wrap up around 1:45, let's dive right in. And there were a couple of questions here around kind of stakeholders, right? And I think you really talked about getting folks at the table and participating. One of our questions has to do with state reps, state regulators, and water agencies. What does it look like for them to participate and use OpenET? What are some kind of use cases you either have seen or hope to see in the future from the tool?
Absolutely. That's a great question. So typically what we've seen is that there was a need for understanding the water use side of the equation a little bit better, and to have meters everywhere all over the place would be just incredibly cost prohibitive. And so a lot of stakeholders and water resource agencies reach out to understand ET data in their state a little bit better and try to understand how to incorporate those data into things like their historical review and planning for the future, and even breaking down the data to develop water budgets in either groundwater basins or surface water. And it can be an incredibly helpful component to help understand how water is flowing through the landscape, either natural landscape headwaters or across agricultural areas that the state is trying to understand a little better. So we typically work with the state water resource agency to help provide them with some, custom and bespoke data sets and to support their training and their outreach efforts as they're trying to share more about ET data and how helpful it can be in places like the Delta and for Sigma compliance in California. OpenET data play a really pivotal role for folks to be able to share their estimated water use back with the state agencies. So we support in a lot of different ways on that front. Colorado River Basin, I went over that a fair amount. So just that's how we're working with folks.
Yeah, great examples of kind of getting the big holistic picture. But it was really interesting to also be able to dig down and see a lot of these individual use cases across the ag space. And we have a question here too from Julia around kind of farmer engagement, right? So how can we get more farmers to adopt this technology? And, in the work and the conversations you've had with them so far, what have been some of the barriers that you've been hearing to adoption, and how are you guys working to work through those?
That is such an excellent question, and it's a huge emphasis for us. We really want to connect. We really want people to be able to understand ET data and how that plays into their operations. So part of the role of the nonprofit is to help coordinate some of those efforts. So we work with our state water resource agencies to attend various conferences where we're going to have a lot of growers and producers. We also work through some of the university extension offices to really connect with growers, and we'll conduct some pretty intensive training sessions with folks. So we have our YouTube channel trainings, but if you know of an extension office where we could reach a lot of growers and producers that way, please let me know in the chat or let Paula know. Reach out to me and we'll set up a time and a place to come and visit. We'll send a group of the consortium partners to come and walk through how to actually use the farms tool, how to use our data to understand how the changes that they're making in their operation are impacting things like their irrigation efficiency or their crop yield and beyond.
Awesome, thank you. Yeah, YouTube tutorials, demos are always good, but it's those live in-person conversations where you really get kind of two-way learnings, which is great. Folks really start to understand how can we use it, and you all, I'm sure, start to really understand, okay, how can we make this even more and more useful? Um, we've also got a couple of questions too about timing and kind of forecasting. And so would you mind maybe just really quickly reinforcing for folks, what data is available and how far back?
Yeah, absolutely. So one thing to note, the Landsat data go back quite a ways. And so we are actually releasing folks have asked for that. And so we're releasing what I would call a more experimental data set for 1985 through 1999. Because of the Landsat missions at the time, these are not as high a quality as the data from 2000 to 2025. But look to the Google data catalog for an expanded data set to be released and for earlier years very soon. After that, from 2000 to current times, we have monthly data that are available through Google Earth Engine. The Data Explorer just has a few years, but the API has the full complement. And we have primarily monthly data there. For a moving window, we have daily data with the latency of just a few days, but that can vary depending on the cloud cover for the most recent Landsat overpass. And so you'll see that vary just a little bit. Our one thing that our team is working on that I didn't mention was forecasting. This is something that folks have asked for. It would really help them with their irrigation scheduling if they could understand ET and soil moisture a little bit better in real time, and even being able to look forward. So this is something our team has been working on and plans to incorporate over the coming year. I think we'll probably start with a short forecast of a few days up to a week. And then depending on how that goes, we might extend it a little bit farther out. But definitely thinking along those same lines. And it's definitely a line of inquiry for our researchers.
Very cool. And I bet a great place to stay up to date on all of that is the newsletter. So if you haven't seen the link
Right.
in the chat, definitely check it out. Um, we also have a couple of questions kind of about crop type too, and kind of really sensing and identifying that. We had one question about, okay, how do you know what's being grown on the ground, right? What's in the field? And also uniquely, right? How are you set up to actually address possible changes in crop type, right? In places like Utah where you can split the season.
That is a great question. The field boundaries that are in the Data Explorer are kind of advisory in nature. So they don't, they are released with some latency from various state agencies and federal agencies. And they're not, always perfectly on time or accurate to what's going on in the ground. Same thing with the crop types that are shared. They're kind of shared as a informational uh, best guess through the Data Explorer. And ET data um, they don't necessarily reflect the actual crop type. So the crop type information we share is more of a courtesy. When you look at ET data, it's changing across the landscape and can be increasing, decreasing. Really, the key thing is to look at a particular area and be able to understand historical trends around ET. And if you have that on the ground, knowing of what it is that you're planting, that combined can be really informative. So, say you're trying a crop switching approach and you know that that's going to impact some of your total consumptive water use from irrigation, it's going to be impacting your ET. You try your crop switching approach and hopefully see a commensurate, reduction or change in your data and in your operation. So this can really help support some of those analyses and understanding change over time.
All right, very cool. And maybe just one last question too, because we do have some questions from folks, who might be interested in adding OpenET capabilities into their own platforms, right? Or even just in general, like there's so much richness here. How do folks know where to start or where to connect to learn more? And I think that that is going to be our last one for today. So if folks do have any more questions, we'll reshare Sarah's information in the chat as well.
Thank you. We always recommend that you start out with our OpenET website. You'll find a wealth of information there. You'll find some of the known issues. You'll find, general ET information, information about the models, and just a wealth of information about our use cases. And you'll also find links to the Data Explorer and to our API and to the Farms tool. So depending on your application, between just taking a look under the hood, creating an account and taking a look under the hood for the Data Explorer, and also tinkering with the API, you can suss out, what kinds of, what level of ET data you need. And then that combined with the YouTube tutorials will help get you started. If you run into any issues, we have a whole team, dev team that is supporting our support emails. So when you run into some issues, please feel free to email the support line and they'll get right back to you.
Wonderful. Well, that brings us to the close of today's session. Sarah, thank you again so much for joining and sharing all of the great work that you guys are doing. Great momentum all around, and so we're excited to kind of stay tuned in and see where this work goes and grows. So thank you so much again for joining us, and thank you to all of you too for tuning in your mornings and your afternoons on your lunch breaks. We love to use this webinar series as a great way to kind of demonstrate all of the great work being done to make water data sharing more open and transparent. So if you are new to the IOW Coalition and our work, welcome. We love to have you on board. Please stay tuned for additional content, newsletters, and webinars. Or if you have an idea for a really great project that is really sharing, can share lessons for others around, what's available out there and how water data can be shared more easily, let us know. We'd love to spotlight you as well. This series is really a chance for us to be able to connect folks across the water data community and have a little bit of time to in our day to inspire and get excited about the great work happening out there because there are a lot of challenges in water data sharing, but there are also a lot of really great examples of success and good work being done. So we're excited to have all of you here with us. Thank you again for joining us here today, and we hope to see you at the next one.